Hi, welcome to my part 2 video of the GAiA web portal. In this video we'll be looking at this section, Advanced Routing. I've decided to cover this section only because there's quite a lot to have a look at and cover. In part 3 video we will configure the rest of it or look at the rest of it. So there's a system management section as well as the 4 sections here. So these 3 as well as the one hiding down here, the software updates section as well. So let's get straight into the video and look at the first section, which is the DHCP relay. So the DHCP relay is used to get IP addresses for the computers on a particular network via a DHCP server on a different network. So with this feature, the gateway sends DHCP requests to a server on a different network, and we can configure that by clicking the Add button here. So the first thing we would do is select the interface on which you want to enable DHCP. So if we click that, I've just got the single interface, and it shows you the IP address of this interface, which is the same IP address I'm using to connect to the GAiA web portal, as you can see up here. We can also specify a primary address, and what this is we would specify the IP address used as the DHCP router address if you have multiple IP addresses configured on the interface. So if this interface has multiple IP addresses, we'd configure the primary one we want to use here. The wait time, this is the minimum time to wait for a local DHCP server to answer the request before forwarding the request through the interface. So this provides for a local DHCP server to reply before attempting to relay to a remote server. So if you've got a local server on the network, it will try to attempt to connect to that first, and it won't bother doing anything. And if this times out to whatever is configured in here, then it will relay to the remote server. The maximum hops. So if the request cannot find the server, then a maximum hop would be wise to configure here, so that it may time out as well. So it's configured by default with 4. As you can see, it's in the slightly dim grey writing within here as well. So if you can change that by just specifying a number here, such as 5, or seconds in here, 60 seconds. And the final part is the relay. So we would specify the IP address of the DHCP server to which to forward the DHCP requests here. And that's it really, we're done on this section. So if I cancel these, we'll go to the next section, which is BGP. BGP stands for Border Gateway Protocol. It's an exterior gateway protocol, and it is actually the exterior gateway protocol used on the internet between ISPs or autonomous systems, or even from customers to ISPs, so services can be reached within the customer's network from the outside world. There's actually 2 types of sessions between BGP routers. There's Ii Gp, which is exterior BGP, and there's Ii Gp, which is interior BGP. Ii Gp is used between autonomous systems, where Ii Gp is used within autonomous systems. Actually, BGP is not recommended for internal organisations to use internally, because it's actually a very slow protocol compared to other router protocols such as Ospf and RIP. And it's technically a distance vector router protocol, but most people call it a path vector protocol. And without tuning BGP, it behaves like RIP because it uses hop counts of autonomous systems, where RIP uses hop counts of routers. And that's really it for as an overview of BGP. What else I can tell you is it's actually a very powerful protocol, and there's lots of various attributes you could configure to determine which path a router should prefer to find their way around the internet. So it's a wise idea to have a good knowledge, good background on BGP before configuring it. within the Checkpoint Management Portal or even the Checkpoint CLI. So we can get started by having a look at the management portal in front of you to configure BGP. So let's start to have a look at the BGP parameters, and the first setting we'll look at is the router ID. The router ID is basically used to uniquely identify the router in the autonomous system, so you'd specify that here. The next one is the cluster ID for root reflectors. Root reflector is like a rule which basically overrules the split horizon rule. The split horizon rule in IBGP is basically any route learned via IBGP will never be re-advertised to another BGP peer. So in certain situations we need to overrule this, and we would do this by configuring a router to be a route reflector to ensure routes are fully propagated throughout the network. The next part is the local autonomous system number. I've given it a 5, and you can configure that from this section here. So there's 3 options, and the first one is the unconfigured, so it's basically unconfigured. The next option is local autonomous system number, so you can specify a number between 1 and 65,535 there. And the next one is Confederation, which goes into a few options within itself. Basically, Confederation is breaking an autonomous system down into sub-autonomous systems using private autonomous system numbers, and this is to replicate routes correctly and also for manageability purposes. Okay, so what we can do is cancel this, and let's look at the miscellaneous settings within this section here. So the default MED, that's the multi-exit discriminator value, which is used to help external neighbours decide which of the available entry points into an autonomous system is preferred or are preferred. So a lower MED value is preferred over a higher MED value, and usually breaks the tie between 2 or more preferred paths. So it's basically used for path preference. The next one is the default gateway, and the default gateway is default route, which is generated when BGP peer is up, and this route has a higher rank than the default route configured in the static routing page. So basically it is advertising a default route over BGP. So the next one is the enable IGP synchronization, and with synchronization all routes learned via BGP must be confirmed by an interior gateway protocol to tell them that they exist before they will be accepted by BGP. So you would select this option to make internal and configured BGP peers check for a matching route from IGP protocols like Ospf before installing a given route. The next one is the enable communities, and this will basically enable community options within the inbound route filter section. So select that, it would enable community options within this section here, which we will be covering very soon. Enable weighted route dampening. This is route dampening which lessens the propagation of flapping routes. So a flapping route is a route that repeatedly becomes available then unavailable. And the next following parameters for BGP is the peer groups. And we get the add peer group. So we can give it a peer autonomous system number here. and the peer autonomous system is the autonomous system number of the external peer group. So we can add an integer from 1 to 65,535 there. And the peer group type is external. If we look at the local autonomous system number, it's 5. We make this a 5, and it means both of them are in the within the same autonomous system, so it makes it internal. But if we give it another number, it's external again. The description is a description of the peer group, so you can give it a description there. The local address, this is the address used on the local end of the TCP connection with the peer. The out delay, that's the length of time in seconds that a route must be present in the routing database before it is redistributed to the BGP. And the next part is the peers. So we can add a peer, and there's quite a lot of options and settings in here, so I'm just going to basically show you them but not really go through them. It gives you a warning, adding a peer will lock the peer autonomous system number. Let's click OK here. So you can specify a peer ID here, and if we click on the show advanced settings, here's where you get lots of optional settings you can configure regarding routes and preferences and etc. Local address, AS path, aggregator settings, MD5 authentication, and all the other types of settings for BGP. So I'll just basically kind of scroll down so you can see them all. And we'll cross this off. And we'll move on to IGMP. So I'll give you an overview of IGMP and then we can have a look at the settings. So IGMP is used for clients to signal they want to use multicast and join a group. In IP version 6 it's called Multicast Listener Discovery Protocol, and it's basically used to establish client memberships, in particular multicast groups, on a network. The mechanism of the protocol allows a host to inform its local router using host membership reports that it wants to receive messages addressed to a specific multicast group. So hosts declare what groups they're interested in, on which routers have to maintain that information, and this is done via IGMP. An example is when multicasting allows one computer on the internet to send content to multiple other computers that have identified themselves as interested in receiving the originating computer's content, such as streaming media on the internet. Okay, so what we can do is have a look at the settings. Just also to bear in mind, for IGMP to work you also have to configure a multicasting routing protocol such as Pim. I think Pim's on the list, so there it is. So Pim's the fourth one down, we'll cover that shortly. So if we click on add, and we can see the IGMP interface you want to enable IGMP on from here. The version, Check Point supports version 1, 2 and 3. And with version 3 it supports source specific multicasting, so that's a big enhancement. And I've not really looked at the majority of these settings, but I'll let you read the checkpoint guide. Query interval, that's the time interval used for queries sent by the query router. You've got some more settings within here. Local groups, which provides a mechanism to simulate the presence of local receivers for specific groups, and static groups provides a mechanism to simulate the presence of local receivers on interface. So I'll let you have a look at these and read more about the terminology of these. The last member query interval, that one is used to tune what is known as the leave latency. So I'm going to cancel out of here. now that you've seen an overview of the settings, and we'll move on to IP broadcast helper. So the IP broadcast helper allows the relaying of broadcast UDP packets on a LAN as unicast to one or more remote servers. So an example of when you would want to use this is when you relocate servers from their original segment and still want the service to be available. The settings are forward non-local packets. Use this option to control whether to forward packets that are not locally originated by a source directly on the receiving interface. If we click on add, there's three options here. The interface, so select the interface on which IP helper service will run on. UDP port, specify the UDP service to be forwarded by the interface. And finally the relay, which is to specify the relay IP address here. And that's all there is to this section. So to give you an overview of Pim, Pim routes multicast traffic for groups that may span wide area networks. It works well with all existing unicast routing protocols, and Pim supports the three modes, which are dense mode, sparse mode, and source specific multicast mode, but you can only enable one of these modes at a single time. In a real world scenario, think of multicasting when a client wants to join a group, like tuning into a radio station or streaming media on the internet. So it's a one-to-many communication for those who want to actually receive it. And looking at the options, Pim protocol, you've got the three options here. The middle one, dense mode, this is a push technology which uses a flood and prune method of finding the receivers on the network. So dense mode assumes there are receivers on most subnets or even all subnets and does not really scale well because of the flood and prune method. Floods the network, and if they are not interested in the multicast feed, they will prune themselves off. So it's flood and pruning, and because it's repetitive, it's inefficient. The sparse mode, which is actually a pull technology, where dense mode was a push, and sparse mode requires the receivers to explicitly join the multicast tree before the multicast traffic is forwarded to them. As the name implies, this works better where the subnets are sparsely populated. But that said, it's still the preferred method even when there is a dense distribution of receivers. And the last one is the source specific multicast. And this is actually a version of the sparse mode. So it's used in conjunction with IGMP version 3 to request or block multicast traffic from specific sources. So in this mode, the only packet that are delivered to a particular receiver are those originating from a specific source address requested by the receiver. And this basically reduces overhead on the network and also improves security as well. Okay, let's look at the Pim interfaces. And the first one is the actual interface that Pim will run on. So you can specify the interface here. I've just got the single one. Then there's the local address. So optionally for each interface that is running Pim, you can enter a local address here. And what this is this is useful on interfaces with multiple IP addresses. So the local address must match one of the addresses configured on the interface. If you're using a virtual address in a situation where you're using VRRP, you could tick this box here. So this is a VRRP address. You tick this box. And the last one is the DR priority. So this is the designated router priority, which is to specify a priority if more than one interface is used. Okay. Let's look at the other options. So you've got various advanced options, which I'm not really going to cover all these, but basically you've got general timers, and you can see in the light grey writing the default and the ranges you can configure, and you've got all these parameters here you can configure, or you can leave them on default. You've got the assert rank, and this is used to compare the cost of routing protocols. in order to determine which route or which router will forward multicast data packets. So you can configure them or just leave them as default. And you've got your sparse mode timers as well, which is the next one. So these are just some timer values for sparse mode. You can configure there. The next one is the shortest path first threshold, and you can configure that here. So if you click on add, you've got some settings here which you can fill out to configure the shortest path first. And then that's it for this section. So we cancel out of here and look at the last setting, which is the bootstrap and rendezvous point settings. So you can configure all that here. Basically, bootstrap and rendezvous point settings is a method. It's an open standard for automatically assigning rendezvous points, which is required in Pim sparse mode. So to configure this router as a bootstrap router, you would provide rendezvous points here, which is used for clients to pull multicast traffic from. And a rendezvous point is basically it's a router that connects to the receiver to a multicast shared tree. Okay, so let's move on to the next section, which is RIP. So to give you an overview of Routing Information Protocol, or RIP, it's an industry standard distance vector dynamic routing protocol, and it's used to exchange routing information with neighbor routers within a domain or autonomous system. It's not as scalable or as flexible as Ospf, which is another routing protocol, in determining the best route, but it's still a very good option for small to medium-sized networks due to its simplicity. It determines the best route using hop counts, where Ospf uses cost. So let's have a look at the settings. You've got the update interval and expire interval here, and can configure these timers to allow you to vary the frequency with which updates are sent and when routes expire. The next one is auto summarization. The checkpoint implementation of RIP version 1 supports auto summarization, so this allows the router to aggregate and redistribute non-classful routes in RIP version 1. So non-classful routes are anything other than the classful ones, which are the 816 and 24 in the 1918 addresses. Okay, so let's look at this section here, so the RIP interfaces. So you'd specify the interface on which RIP is enabled on from here. You can specify the version, so by default it's version 2, and there's key differences between 1 and 2. I'd suggest you Google them just to find out what the differences are. Oops. The metric, so this is the RIP metric to be added to routes that are sent using the specified interface, and the default is 0. Accept update, so this is whether RIP packets from other routers using this interface are accepted or ignored. Send updates, whether RIP packets should be sent by this interface. Virtual address, so GAiA spots the advertising of the virtual IP address of the VRRP virtual router, so if you tick that, you can use the virtual IP address. Transport, so you've got multicast and broadcast here, and multicast is you'd select this when you'd be using RIP version 2 package, which should be multicasted on this interface, which is the default. And the broadcast one, select broadcast, which specifies that RIP version 1 packets that are compatible with version 2 should be broadcasted on this interface. And the final one is the authentication type. And if we have a look at the options, so you don't have to configure authentication between RIP routers, or you can use simple authentication, and finally you can use MD5 to make sure it's the authentication is protected on the wire. So, that's it for this section. So if we cancel out of here, and we are done with RIP, so let's move on to Ospf. So to give you an overview of Ospf, Ospf is a link state dynamic routing protocol, and it's used to exchange routing information between routers. So it's more complex than RIP, but it's more scalable and efficient than RIP. And Ospf uses concepts of areas, virtual links, LSAs, and lots of other concepts within Ospf. So you should have a very good overview of Ospf before doing any configuration with Ospf. So let's have a look at the settings. So global settings, the root ID. This is to uniquely identify the route in the autonomous system. This I don't really know what it is. RFC 1583 compatibility, but the checkpoint guide says it's an implementation of Ospf, which is based on RFC 2178, which has fixed some looping problems. The Spf Delay, this specifies the time in seconds the system will wait to recalculate the Ospf routing table after a change in Ospf topology. The Spf hold time, this specifies the minimum time between recalculations of the Ospf routing table. And the default ACE route cost, so default ACE stands for Autonomous System External, which specifies a cost for routes redistributed into Ospf as ACEs. And the route types, you've got type 1 and 2 here. And basically, a type 1 route has a more accurate path in general, since it adds the cost on links inside the Ospf network, so the cost of the external links, where type 2 route only has the cost of the external link no matter how many links it passes through the internal network. So you've got two types, and it's to do with the cost of the links. One adds the cost and one doesn't. Okay. And finally you've got the graceful restart helper. This basically helps with route flapping. So let's look at the interfaces, and there's quite a few settings within here as well. So the first one is just to specify an interface and to configure Ospf on. You've got hello, dead and retransmit timers here, so you can configure those here. So the intervals to send hello packets, and the retransmission interval as well. Ospf cost, so this is which specifies the weight of a given path in a route. So the higher the cost you configure, the less preferred the Ospf route will be. So you'd configure that here. Just having a look around. So the election priority, this would specify the priority for becoming the designated router on this link. So Ospf has this concept of designated router and backup designated router, and I suggest you look at some Google articles on that to become familiar with it. Okay. Passive. So this mode enables the network associated with the interface to be included in the intra-area route calculation rather than redistributing the network into Spf and having it as an ACE. Virtual address. So you could use the VRRP virtual IP address as the IP address for the to run Ospf on. You've got your authentication types. So you've got your none, simple, and MD5 authentication types here. Just like RIP, they're the same as RIP, the terminology for them. Actually, the one I've missed is the area. So we've got one area here, and it's the backbone area. We can configure other areas as well, which I'll show you shortly. But area is a huge subject within itself. The best way I can explain areas is if you've got lots of routers, and you can group them into areas, so you'd specify group routers in particular areas, and that's to make the Ospf domain more efficient. So you can summarize at each area border router, so it's not flooding the network with too many LSA packets, Ospf packets, and it just makes everything more efficient and runs a lot more smoothly. Okay, so let's cross this section off, and let's have a look at this option, virtual links. I don't think there's a lot in this option. There is. You can read the guide to have a look at what all these you need to adjust all these for, the meanings of them, but basically virtual links is used in a situation where with areas everything has to connect to the backbone area, so any other area 1, 2, 3, 4, 5, they all have to connect directly to the backbone area, and the backbone area is area 0. But there's scenarios where an organization cannot connect to the backbone area, so you can use virtual links to connect that area to another area which connects to the backbone area. That's the best kind of explanation I can give, but again, read some terminology on virtual links before doing anything here. And the final one is areas. So you can configure areas from here, and there's different types of areas actually as well. So there's 3 types, and you'd give it an area number, so area 6 for example, and you've got the area types of normal, which is just a normal area type. You've also got stub and NSSA. So stub areas is a type of area that has no knowledge of other networks and will typically send all of its non-local traffic out by a single path, with the network aware of only a default route to non-local destinations. So when I say route, I mean route if you're from the States, by the way. The other option is the NSA, so that stands for not so stubby area, and as you can see the options change as well when you select any of these. Let's have a look at the normal one. Okay, so the not so stubby area, this is basically a stub area like this one, although with this one the difference is it allows the injection of external routes via type 7 LSAs from an external source. So when I say external source, I mean a non-Ospf domain. So imagine a RIP domain injecting their routes into the Ospf domain or BGP domain or something like that, so something external. Okay, so you'd want to read on these. I'm not going to go through each individual one, and you can configure the address range and the stub networks from here for the NSSA as well, or any of the others. Okay, so we'll cancel out of here. I think I've covered the Ospf management portion. We're not going to cover IP version 6 Ospf. I've not really looked into it, and it's probably exactly the same as this, apart from it uses IP version 6 addresses. So the next one is route aggregation, so we'll go into this. So route aggregation, which is also known as supernetting or route summarization, is a method for generating a more general route from a number of specific routes. So you would use this method to reduce the number of routes advertised for a given protocol, and so this action basically reduces the number of routes advertised. If we click add here, we could configure this. So here you could specify the address of a route that activates the aggregate routes if contributed by the protocol. Specify the subnet mask. The rank, the route system uses rank when there are routes from different protocols to the same destination. So for each route, the route from the protocol with the lowest rank is used. The weight is similar to the rank, but it's a second tiebreaker after the rank. And it selects routes going to the same destination, and the route with the highest weight is an active route and is installed in the kernel forwarding table and redistributed to other routing protocols. The AS path When this is selected, the AS path is truncated to the longest common AS path. And then you can finally specify your contributor protocols from here. So if we click Add, and we can specify a contributing protocol whose routes activate the aggregate route from here. So we've got all these options. And specify the IP address of the aggregated route being created here. The contribute all route, when this is selected, it lets any route contributed by the protocol activate the aggregate route. The subnet mask, so we'd specify subnet mask here, and finally the match type. If none is selected, it matches any route that equals the specified route or is more specific than the specified route. And if it's refined, that matches a route only if it is more specific than the specified route. And finally, exact matches if it's exactly the same. Okay, so if we cancel out of here, and we can move on to the next section, which is inbound route filters. So using inbound route filters, we can create filters of prefixes that are accepted into RIP, Ospf and BGP from here. So Ospf and RIP are accepted by default. For BGP, no routes are accepted from the peer by default, so you must configure an explicit inbound BGP route filter to accept a route from a peer, and we can configure these from here. So you've got two here by default already within the settings. And this is for importing to Ospf. Routes is all routes and accepted by default, and that's same for RIP as well. Okay, so let's have a look at the options we can add. And the options we can add is the add BGP policy based on the AS path. I believe that's for using regular expressions, and the add BGP policy based on just the AS, and you can also add individual IPv4 routes. So I won't go into all these settings here, but just to show you the settings you need to configure or optionally configure. In particular, the local preference and the weight are used to control routes and to prefer routes one from another. So the highest value wins in both of these attributes. So you can configure these as well. Let's have a look at the BGP policy based on AS path as well. So here's the settings for that. And finally, we can just add an individual IPv4 route from here. So we can import it into either Ospf or RIP. We can specify the route. We can specify the match type. We can specify the action of accept or restrict, and give it a rank number. That's optional. Okay, so let's cancel that. Let's move on to route redistribution. Route redistribution, this is used for when you are injecting or advertising routes from one routing protocol into another routing protocol. So this is similar to route maps for an export policy. And actually with route redistribution, you can only configure this using the web UI. So usually you can do lots of things, more things within the CLISH than you can within the web management interface. But with this, you can only configure this within the web UI. That said, you can configure route distribution using the CLI using route maps as well. So if you go into CLISH, you can configure these properties using the route maps functionality. So let's have a look at the options. So here's the protocols you can redistribute. Let's just click on static to protocol. So the destination protocol we can specify. It shows the from protocol is static. Static route. You can specify the route here. And give it a metric, so the cost of the created routes in the destination protocol. Let's just look at another couple. Ospf, since it's the most popular one. So again, to protocol here, The from protocol is Ospf version 2. Specify the routes, the match type, the action to accept or reject, and give it a metric as well. Now let's just look at another one. Let's go for BGP, and again here are the options for BGP. So let's cancel this and let's quickly move on to routing options. So here you've got various routing options. The first one is the equal cost path. So you can specify a value for the maximum number of equal cost paths that will be used when there is more than one equal cost path to a particular destination. So we've got 8 here at the moment. The kernel option, this is when a VPN tunnel is created. Route injection mechanism updates the local routing table of the security gateway to include the encryption domain of the VPN peer. So for the routes to remain in the kernel, you must configure this option, or just enable it. So you can just tick the tick box from here. The protocol rank, so by default they're all ranked. So Spf is ranked with 10, RIP 100, BGP with 170, Spf ACE routes 150. So if you've got more than one of these configured and you wanted to change the ranking, let's say you wanted to trust RIP over Ospf, and you'd adjust that and give it a lower rank number within here, so it's lower than the default of 10. So you can adjust that as required from here. Now let's go down. So you've got advanced routing options, and there's the single wait for clustering here, and this is using clustering environments, and if checked, it does not start the routing protocol if the cluster state is down. And then you've got the trace options. So you can enable trace options for log information about errors and events. Logging is configured for each protocol or globally, so logging is not generally turned on due to normal operations, as it can decrease the performance. So just turn it on when you really need it. And the log messages are saved in var log routed.log file. So you can adjust these from here, and you can filter visible tables below, so you can filter it. Let's go for BGP here, and then you could enable these settings within here, so depending on what you need to log on. So we just click that, double click it, activates it. If you double click it again, it should deactivate it, or you can just press these buttons here as well. Okay, let's go back to show all, and let's just scroll down to the bottom so you can see all the different protocols. Okay, so let's move on. Let's go back to the top and let's have a look at router discovery. With router discovery, you can automatically discover a default router using this method if enabled on the Check Point GAiA. You can also read the description above here to find a little bit more about what router discovery is, and that's for any of the other features here. There's always a description near the top, so you can read that. So if we click on Add, we can specify the interface on which to enable router discovery. Enable it from here. We can specify some advertisement intervals from here. If we specify an interface, it should populate the bottom area here for us. If we click it, we can edit it as well. So that's the advertised address. So whether the address should be advertised in the route advertisement packets, this applies to each address on the interface and not to the interface itself. Eligibility, so you can make an IP address eligible or ineligible as a default root address, and a root address that is not to be used as a default route has a preference of 0, which is this part here. Okay, let's cancel that and let's move on. We're not going to cover IP version 6 router discovery. It's probably exactly the same as the router discovery portion, apart from it's using IP version 6 addresses. So let's move on to policy-based routing. With policy-based routing, you can control traffic forwarding. So when you use policy-based routing, you create routing tables of static routes, that's the action tables, and direct traffic to the appropriate tables using policy rules. So we've got the action tables here, and we've got the policy rules here. So the action tables define the static routes, that is where the traffic is sent. So you can define the destination of the route and the next hop gateway to that destination. So let's quickly just fill out an example. You can also use the default route, or you can specify the destination here. So I'm just specifying any old destination. I'm specifying a host, so we'll give it a 32-bit subnet mask. You can also specify the type. We've got 3 options here, and the description for them is just below here, so I won't bother reading these out. Add gateway, you can add it via IP address, next hop IP address, or network interface. I'll go for network interface since it's going to be a little bit quicker. You can also specify priority if you've got a few of these. Click OK, click Save. So we've got an example here. And with policy rules, you will specify what traffic is matched, and you can route traffic by matching on one of the following. So here, you can match on the interface, the source, network address, or the destination. And you can prioritize it if you've got one or more of these policy rules. Let's just give it a number, and you can also give it an action of table, so it will action on the route within the table just created earlier here. So if we specify the table and specify the table test, we can give it a source address or source network. So I'm basically saying the source is 192.168.0.0 with a 24-bit mask. Execute the action table called test. We can save that, and job done. So I don't think there's anything below here. Okay, so I think we've kind of quickly covered all these sections. The last one actually is the routing monitor. So you can monitor your routes from this section. All routes are shown here, so you can filter on protocols here. So if I click on static, it will just show me the static route here. And the one other thing I haven't showed you is we have the monitoring tab here, but you also usually have the configuration tab as well. So with all the other sections I've been covering, we've been in the configuration tab. So if we go to, let's say, policy-based routing, we've got the monitoring tab and the configuration tab, and we've got the configuration tab selected. So you can go to monitoring to monitor your configuration, and you can see the output here. Let's go to another example. A good one is, I think routing options is a good one. So if we go to monitoring routing options, yeah, so you can look at your log files, and you can select your log files from here. You can specify the number of lines. So you can do this from most of these features. You've got the 2 tabs, the monitoring tab and the configuration tab. Let's click monitor just to show you what the interface looks like. BGP, monitoring, so not much going on with BGP, probably because it's inactive, so it did say it's inactive. Monitoring for IGMP, again it's inactive, and so it's pretty much the same for all of them by the looks of it. Okay, so that's it for this video, and I'll be doing another video very shortly of the rest of the GAiA management interface.